Okay. Does anyone remember what rise over run means? Yeah.
Yeah, so you would start 7 and you would go down to the right one.
Yeah, you're close. You're super close. So the rise over run, the number on the top of the fraction tells you how far to go up and down. If your number is positive, it's telling you to go up. If your number is negative, it's telling you to go down. And then the run part, I tell students for the run part to always go to the right unless you run out of room. So for this one, you were exactly right. We're going to start at 7. We start at the y-intercept. So 1, 2, 3, 4, 5, 6, 7. And then, are you guys ready? Are we ready? Okay. And then we're going to rise 1 and run 2. So we're going to go up 1 and to the right 2. Up 1 to the right 2, up 1 to the right 2. And then if you run out of room, you can do the backwards version. So we can go down 1, left 2, down 1, left 2, down 1, left 2. On this one, we have a slope that is not written as a fraction. So how could I take the whole number -2 and write it as a fraction? Put it over 1, yeah. So on this one, where should we start? 1. And then what should we do from there? Down 2, and we're going to go right 1. Down 2, right 1, down 2, right 1. And then if I run out of space, I can go backwards. So up 2, left 1, up 2, left 1. Jog in our memory? You remember that? I don't know? Okay. All right. The next method is called the cover-up method. We use this on equations that are in standard form, where the x and the y are on the same side, and we do it when we're feeling lazy. So if you guys think about it, if you're looking at a point that is on the x-axis, what is the y-coordinate on the x-axis? What's the y value of a point that's on the x-axis? 0, right? It's 0. So the cover-up method says if I'm looking for the x-intercept, I would plug 0 in for y. What is 4 times 0? 0. So I would cover this up, and I'm going to solve the equation 3x equals 12. So 3x equals 12. What does x equal? 4. So that means that the x-intercept is 4. If I wanted to find the y-intercept, what would I plug in for x? So if we think about all the points that are on the y-axis, what is the x value at all of those points? The x value, so if we have the x value right here, or the x value right there, or the x value down here, we're right in the middle, so what is the x value? Should be 0, right? The x value at a y-intercept is always 0. So if I plug 0 into the equation to find the y-coordinate of the y-intercept, I plug 0 in for x, and what happens when I do 3 times 0? It cancels out, right? So the cover-up method says if I want to find the y-intercept, just cover up the x's, and you get 4y equals 12. So what's the y-intercept? 3. So it's a slightly different way of graphing. It works if you're being lazy and you just don't want to do the rest of the work. Okay. If you look at this one, would the cover-up method work okay for this one? No. Yeah, you could do it, right? So if we're looking for the x-intercept, we can cover up the y. We get negative 2x equals 9. So what would the x-intercept be? 9 divided by negative 2 is 4.5. It's negative 4.5. So 1, 2, 3, 4.5 is right there. If we wanted to cover this up to find the y-intercept, what would the y-intercept be? Negative 3. Okay, so the cover-up method worked just fine on that. We also want to make sure that if we have to, we could solve for y to get the equation into y equals mx plus b form. So that's what we're going to do on this one. We're just going to make sure we graphed it correctly by solving for y right here. So if I needed to solve for y, what's the first thing I would do? I want to get the y all by itself. I'm going to add the 2x to the other side. Right? So if I'm trying to solve for y to get it in y equals mx plus b form, I'm going to add the 2x to the other side.
Negative 3y. Negative 3y.
Do I add these together and say it's 11? No. What should I write?
Negative 3y plus 2x equals 9. I mean plus 9.
2x plus 9. So I was showing you guys the cover-up method, and we used the cover-up method twice. And now we're looking at another method for how to graph these where we get y by itself. Okay. So we are really close to the y being alone. What do we have to do to finish it? Divide by negative 3. Good. And I'm going to divide by negative 3 all the way through the problem. So every single thing gets divided by negative 3. And so that leaves us with the slope-intercept form. The slope is negative 2/3. Now I can see that the negative was on the bottom of the fraction, and I went ahead and moved it to the top because in math we typically put it in the middle or put it on the top. But you could have left it on the bottom. It's not wrong to leave it there. So you just have to have a negative somewhere in your fraction. So negative 2/3 x, and then what should I put on the end? Minus 3. And does that fit what we graphed here?
Yeah.
So we have a y-intercept at negative 3. And it would be going down 2 to the right 3, yep, or up 2 to the left 3, which does match what we drew. We got it right. Okay. We good? You remember that? Yeah. Okay. So for this part where you are graphing inequalities, do you guys remember how inequalities look when you graph them?
Yeah. Like when you shade.
Solid line, dotted lines, and shading. Yeah, yes. So when you have solutions that are on the line, that's when you're going to have a symbol that says less than or equal to or greater than or equal to, and that is going to be a solid line. And that's because points that are on the line make the equal to part of the inequality true. Solutions that are not on the line are going to be a less than sign or a greater than sign, and those are going to be dotted lines. And so that would be in a circumstance where if we were looking for solutions to the inequality, we would only be able to look in the shaded area. We couldn't look anywhere else. Okay? So for this one, let's go ahead and graph y is greater than 2x plus 2. How do we graph that? So where do we start?
Two.
And then where do we go from there? Up to right 1, up to right 1, up to right 1. And then I'll go the backwards way as well. And when I connect those points, should I use a solid line or a dotted line? Dotted.
That's me shade on top.
And then we have to figure out where to shade. You guys remember how to know where to shade?
Shade on top. It says greater.
Shade greater than. It depends on the format of the problem. It depends if it's y equals mx plus b or the standard form. So what I typically do is I pick a point that's on one side or the other side. So pick a point on one side of the line because you're going to have solutions either on the left side of the line or the right side of the line. And solutions are going to make this true. So what is the easiest number to plug into something? 0 is the easiest number, right? So if you look at the point 0, 0, that's an x-coordinate of 0 and a y-coordinate of 0. Is that on the right side of the line or the left side of the line?
Right.
It's on the right side of the line, okay? I'm going to go ahead and plug it in. So I've got 0 for y is greater than 2 times 0 plus 2. So that gives me 0 is greater than 2. Is that true or false? That's false. So this side is false. What does that mean about this side? It's true, and that means that it should be shaded over here. So all the solutions to the inequality show up on this side. That's what that means. Is it possible for us to find two solutions that are on a dotted line? Do you have solutions on a dotted line? Do you have solutions on a dotted line?
Nope.
No, solutions are not on the line. All right? So we're going to say not possible. Is it possible for us to find solutions that are not on the line? Yeah, where do we have to look? The shading. So can you guys give me a point that's in the shaded area? Negative 2, 1 is over there. What's another point over there? Negative 3, 1. What about the point negative 10, positive 10? Would that be in the shading? Yeah, negative 10, positive 10. What about negative 50, positive 1,000? Yes, it would be in the shading. It's just off my graph. So negative 50, positive 1,000. So somewhere, just somewhere over here, right? Okay. All right. Scribble this one out. I want to do one in standard form. Sorry. We are going to graph 3x minus 2y is less than or equal to 6. That's what we're going to graph. Do you guys want to do the cover-up method, or do you want to solve for y?
Solve for y.
Solve for y? That's okay. All right, so how do we solve for y? Subtract the 3x. So I'm going to go ahead and do this, and inequality symbols can get kind of messy when you're solving. I'm going to go ahead and leave this up right here. I'm going to solve this with an equation because I know I can graph the line from that. But then I'm going to go back and I'm going to use my shading based off the original. Yes? Yes. But a lot of students don't, and in this particular type of problem, they end up messing up a lot. And when you mess up, you shade the wrong side, and that's frustrating. So when we figure out to shade, we'll go back to the beginning. So we're going to go ahead and minus 3 from each side, right, with the 3x. We got negative 2y equals negative 3x plus 6. And then what should I do with that negative 2? Divide. So I'm going to divide by negative 2, divide by negative 2, divide by negative 2. And so the equation that I'm graphing is what? So negative over negative is positive. Okay, so positive 3 over 2x. What's positive 6 divided by negative 2? Negative 3. Okay, so we are going to start this graph at negative 3. And then where do we go from there? Up 3, right 2. Up 3, right 2. Is this going to be a dotted line or a solid line? Solid. Okay. And then I'm going to use the point 0, 0 again, because that's easy to plug in and I like to be lazy. 0 for x, 0 for y. So when you plug it in, we're always going to go back to the original inequality to plug it in, because we could have made mistakes over here. So we want to make sure that we just plug it in the original. So I'm going to say 3 times 0 for x minus 2 times 0 for y is less than or equal to 6. And what does that give us? Is that true? That's true. So 0, 0 is right here, and this is true. So what side is this? False. And where do we shade? We shade on the true side. Now, we have a solid line this time, so is it possible for us to find two solutions that are actually on the line itself? Yes. So let's just look at some points. We have the point 2, 0. We can write that down as a solution. What's another point you guys can see on the line? We got this point. We got that point. So over 4 up 3, I see that one. What's another one? Anyone see another point? 0, negative 3, okay. And how about solutions that are off the line, that are not on the line? Yeah, 0, 0 was a solution. We know that because we plugged it in. What's another solution? Anything over here? We got lots of answers. What about like negative 5? Negative 5, 4 would work. What about negative 9? Negative 9, 8 would work. Can you guys give me another one? Negative 1. Negative 1, positive 1 would work. Okay. Does that make sense?